bidirectional triode thyristor is known as dash and can be turned on by dash. Okay, a bidirectional triode thyristor is nothing but an triac. Okay, now what is the symbol for triac? Triac symbol is this one. This is anode, cathode, and we have gate. Okay, it can be turned on by positive pulse and on either side negative pulse. If you see the characteristics of triac, it is similar to that of thyristor in positive cycle as well as in negative cycle. That means you can turn on in positive or negative cycle. Option is D.
We need to find out the value of I. Here means we have to integrate over the contour which is given where mod z equals to 2. So within the contour given by mod z equals to 2, there is only one pole, that is z plus 1. Means we need to calculate the residue at that point, that is here I is nothing but summation over residue at z plus 1, that is e power minus 1 divided by 2, which is plus 0 at z equals to minus 3. Hence it is going to be 1 by 2a, hence option A is correct.
If A is an orthogonal matrix, then we have to find the value of determinant of A. So it is given that A is orthogonal. Orthogonal is nothing but A into A transpose or A transpose into A will be always equals to I. Now if I apply determinant to the above equation, A into A transpose determinant equals to, so we can write this as A transpose is equals to 1. Now also we know that A transpose, determinant of A transpose and determinant of A are equal. So we can write this as determinant of A square is equals to 1. So the determinant of A will be plus or minus 1. That is option D. If A dice rolled and is saying that A denotes the event of obtaining a number less than or equal to 5, whereas B is the event of obtaining a number that is odd number. Then we have to check which of the given options is correct. Now A is an event of obtaining number less than or equals to 5. So there are totally 5 chances. It could be 1, 2, 3, 4, 5 out of 6 chances. And B is an event of obtaining an odd number. Odd number can be 1, 3, 5. So there are 3 chances out of 6 chances. Next, let us see what will be the intersection part. That is A intersection B. A intersection will be again 1, 3 and 5. Now what will be the probability of intersection of A and B? We have 3 chances out of 6 chances, which will be 1 by 2. And what will be the probability of B happening of event B? There are 3 chances out of 6, which will be half. Now let us calculate the value of P of A by B. We know that P of A by B is nothing but P of A intersection B by P of B. Let us substitute these values. P of A by B is nothing but 1 by 2 by P of B is 1 by 2. So the value is 1. Hence option A.
Consider a system with open loop transfer function g of s is equal to 1 by s plus 1, 2s plus 1 and 5s plus 1. He has given 3 poles in this transfer function. Okay. The corner frequencies are minus 1, minus 0.5 and minus 0.2. There are 3 corner frequencies. Match the range of omega in group 2 with the slope of the asymptote of the log amplitude ratio versus log omega plot in group 2. Now let us plot here, Bode plot. Okay, we have 3 corner frequencies 0.2, 0.5 and 1 respectively. Okay, now since there is no pole at origin, this is slope will be 0 up to first corner frequency. Okay, since first corner frequency we have pole, it will decay. This is minus 20 dB per decay. Okay, after that we have one more pole at 0.5. This is minus 40 dB per decay. After that we have one more pole, that is at 1. This is minus 60 dB per decay. Now look at the group 1 where P is 0 less than omega less than 0.2. Okay, between 0 to omega, now what is the slope here? 0 dB per decay. Okay, so P is option 5. Log amplitude ratio, this is log amplitude ratio versus log omega. Okay, so this is 0 dB per decay, 0 less than omega less than 0.2, corner frequency is 0. Now what is about Q? Q he has given as omega is greater than 1. Now what is when omega is greater than 1? When omega is greater than 1, we have minus 60 dB per decay. This is 20 log amplitude ratio is equal to minus 60 dB per decay. Now what is log amplitude ratio? Which is equal to minus 3. So Q is given as minus 3. So P5 and Q is 2. Option A. 100 megawatt power station delivers 100 megawatt for 2 hours and 50 megawatt for 6 hours, and it is shut down for remaining hours of the day. Okay, it is also shut down for maintenance purpose in a year, a total of 50 days. Now we have to calculate annual load factor. Now what is energy per day? We have energy per day is equal to 100 megawatt into 2 hours plus 50 megawatt into 6 hours. So this is equal to 500 megawatt. This is of 8 hours per day. Okay. Now what is energy supplied for annum? 500 into, since 50 days is used for maintenance, so remaining days is 315 days. So 500 into 315, which is equal to 1,57,500 megawatt hour. Okay, this is total energy delivered in a year. Okay, now what is annual load factor? Annual load factor is equal to energy delivered in a year, that is 500 into 315 by, okay, 100 into 315 into 24. Now what is this one? Which is equal to 0.81. Okay, what is this one? This is 100 is P power. Okay, you can say annual load factor as average power, or you can say total power by in a year by P power into annual period into 100. Okay, this will use you load factor percentile. The total power in a year we have given as 500 into 315 by peak power is 100 megawatt for 2 hours each day. So this is 100 into annual period is 315 into 24 hours. So we will get load factor as 0.21, that is option A. A single core cable working on a 32 kilovolts 3-phase system with maximum dielectric stress is 60 kilovolts per centimeters. Now we have to find most economical conductor diameter. We know electric field density is equal to V by R into ln R by R. I can also write this one as V by, okay, this is D by 2 ln D by, okay, small d. Okay, now for most economical size of the conductor, we know that R by R is equal to E. Okay, he has given E is equal to V by, this is D by 2 into ln E. So I can write this one as conductor diameter D is equal to 2V by E. Okay, this is maximum electric field intensity. Now what is D here? D is equal to 2V. Now what is V here? 132 kilovolts. So this is 132 by root 3 is the phase voltage we have, and he has given maximum dielectric stress as 60 kilovolts. Okay, be careful with units because he has given us maximum dielectric stress. Now what is the relation between RMS and maximum? RMS is equal to maximum by root 2. So this is 60 kilovolts by root 2. You will get it as 3.6 centimeters is the most economical conductor diameter for the single core cable. That is option A.